Boeing VTOL quadcopter competition. For it, we were given by 3D Robotics a base quadcopter kit. From that, we put that together and assembled it, learned everything we could from it, and then we actually changed it to what you see here, which we changed out the aluminum bars for carbon fiber. We put on much larger motors and much larger props, as well as the entire pickup apparatus here. The main goal of this competition was to pick up weighted tennis balls from a corral and securely fly them 50 feet and be able to drop them off into a trash can securely. Consisted of picking up as many balls as possible. Our design below can pick up 5 tennis balls, which at their heaviest weight is about 400 grams. So to do that, we needed significantly more lift, so we then looked to change the motors and propellers. For that, we looked at over 4,000 different manufacturers and different combinations, and we found these, which are the Tiger motor 600 kV with 15-inch props. They are APC electrics, and their pitch is 4 inches.
There is a significant weight reduction from the composite arm and the original aluminum arms. For an individual arm, that is about a 40% weight difference we're looking at. Now, that was very important because, as we know, composite material, because of its matrix pattern, has a high tensile strength and also is a very lightweight material. The other great thing about this is that we were able to get this at a very convenient price, and there was a good amount of availability of the composite at that time. For the material selection for the pickup mechanism, we wanted to go with a lightweight yet impact-resistant material, and for that we chose polycarbonate. Now, the important part about this is that this polycarbonate material is part of our landing mechanism as well, and not only the pickup mechanism. So we wanted a very robust and rigid material to serve this purpose, and that is why we chose polycarbonate. The impact-resistant polycarbonate was taken over to a learning factory and water jetted to the precise size and shape that was necessary for our pickup mechanism.
To explain how our mechanism works, I want to talk about these 2 discs we have here first. Each disc has 5 pie-shaped wedges that have been cut into it. This allows each disc, or each wedge in each disc, to hold 1 tennis ball within each cutout section. In order to pick up the balls, we rotate the upper disc 36 degrees left or right. This allows us to trap the balls inside. They're pretty sturdy, they don't fall out. And when we're ready to drop the balls, we just rotate it 36 degrees back and the balls drop out. Now, this is done using a central shaft. This shaft is connected to a bearing and a servo motor. The servo motor is in turn what does the rotation. It is a 90-degree limited servo, so we do 36 degrees left or right to give us some freeway in how we want to move depending on how the balls are located and situated.
The battery we used is provided by Boeing company, which is a 4,000 mAh LiPo battery, can provide 11.1 volts onto the quadcopter. Each battery can provide about 5 minutes efficient flight. We connect 2 LiPo batteries in parallel so that each time we can provide 10 minutes efficient flight. That makes us only need to swap out the battery once during competition to make it up for 15 minutes. We use the autopilot to control the behavior of the quadcopter. It will send PWM signals to the quad motors. We also have a separate system to power up the servo motor, where we have a 900 mAh 4.8 volt battery to power it up.